Welcome back to another exciting lesson. In this video, we are going to learn how to determine the hybridization of an atom in a molecules. So you already learned how to draw the Lewis dot structure and know how to interpret a Lewis dot structure. Now we are going to learn to identify the hybridization of an atom. Now, hybridization occurs because we have multiple orbitals, or at least two orbitals combine and form a hybrid orbitals. Hence, we have the term hybridization. Now, it is based on the number of groups, okay? Specific groups. Now, that group can be consist of atoms, groups, or lone pairs. So each lone pair is considered as one group attached to that particular atom. So any type of bonds, single bond, double bond, or triple bond is counted as one group. Now I'm going to show you what I mean by that. Before we look at that, we have to realize this is really tricky because notice how they write out the Lewis dot structure, but they skip a lot of important information. For example, we look at H3C. We can see that right there. This hydrogen is bond to carbon. And right here, we have this carbon right here bond to oxygen with a double bond and bond to another oxygen with a single bond. But look up here. What do you notice? We don't have the lone pair, so we have to realize the lone pair is there because we don't have 2, 4, so we're missing 4 electron total. Of course, it must be a lone pair. And the same thing down here. Notice how I draw this group together. This is bond to the hydrogen. So be careful with the hydrogen. It is very tricky, okay? So every time you see that, we know that that hydrogen make a single bond with this particular atom. So if this is a single bond, then this is a single bond. So 2, 4, that means 4 is going to be lone pair electron, or 2 lone pairs electron. Now in terms of hybridization, you can think of the shape. Linear is basically a line. It looks like a line, right? Trigonoplanar, it look like, look at this triangles right there. And tetrahedral, you can see there are 4 sides. So keep that in mind. Now let's look at this problem. We are going to determine the hybridization of each central atom. First, we are going to look at this carbon right here. So the way it works like this, we have to realize when we have two groups, one is coming from the S and the other one must be coming from the P. Where we have 3 groups, one is coming from the S, okay, and P has a possible of 2. Combined together, 2 plus 1 give you 3. But when we have 4 groups, we have 1 coming from the S, and we already learned that the S sublevel can only have 1 orbitals, and therefore it makes sense it only has 1. And now let's look at the P. In this case, we have 4 groups, so the P must be 3, because 3 plus 1 give you 4. Now let's go back up here and look at carbon. So in this case, carbon has how many groups? Well, we have 1 here from this hydrogen, the other one here from here, we have this one from there, and then we also have this whole entire thing from here, and therefore this is sp3 because there are 4 group total, okay? So I'm going to circle 4 right there. Now let's go to this carbon. We have this carbon branching off, and you notice 1 group right there. And then this coming over here. So this whole entire thing is attached by this single bond. So it's 2 group total. And now we have another one over here. So we have 3. So therefore this is sp2. So I'm going to label this 3. Okay, so it's 3 groups. Now let's go back up here. Oxygen, you can actually label this as well. So in this case, oxygen is attached to 1 lone pair, 2 lone pair, and 3. So therefore we have 3 groups. So therefore this is sp2 as well. 3 group. Now let's go to this oxygen. We have 1